go ahead and get this started. Today, I'm going to talk about Embedded Composer. For those of you that don't know me, my name is Beau Simensen. I have been working for my own company for the last 5 years, doing consulting, a couple of big clients here and there. They keep me busy and let me work on fun stuff in my free time. dflydev is also my vendor, so if you see dflydev packages rolling around, it's stuff that I've been working on. I actually work for a couple other companies. I have a couple other projects that I'm working on, one of which I get to talk about today. I'll talk about that in a couple of minutes. But first, I want to get an idea of who here has never heard of Composer. Awesome. Who here doesn't know Composer very well? Okay. Who here has looked at Composer and thought, I bet that would be a really good way to manage plugins? Yeah, a couple of people. Okay. Who here looked at Composer and immediately thought, I need to create software that doesn't exist yet, specifically so I can try to do plugins with that application? Okay. So there's one other person like me. That is basically the genesis story for Sculpin. Sculpin's a static site generator. I've been working on it for the last 2 years, off and on. It's basically been my playground. Shortly after I found Composer, I started wanting to build an application based on Symfony console commands. And Sculpin is a command line application that uses Symfony console. Eventually, Sculpin was based around HTTP kernel, but not using the HTTP request cycle. There's been a lot of people talking about HTTP kernel. Everyone talks about it being around HTTP request. Sculpin does not do anything with that. It doesn't include framework bundle, nothing like that. It's using all of kernel, but not in any way to serve HTTP. I got to work with React HTTP server. Who here has worked with React? Who here has written React? Anybody? React is really cool. If you haven't seen it yet, it's a great asynchronous library. Lets you do things, talking over sockets and asynchronous communication, all sorts of stuff that a lot of people don't think PHP can do. React lets you do that. It enabled me to put an embedded web server into Sculpin. Has anyone used Jekyll? Jekyll, okay. Jekyll uses the embedded Webrick server, or at least it did a couple of years ago. This is basically that. It lets you have an application that sits and listens to port 80 or whatever port you want, and it ties into the rest of your application. And finally, Sculpin let me play with Embedded Composer, which was, as I mentioned, one of the main reasons I decided to write Sculpin to begin with. The features that I had in mind that basically required that Composer be embedded into Sculpin were that Sculpin needed to be able to support plugins and extensions on a site-by-site basis. This would be the case where one website you want to have Bootstrap. Another website you want jQuery and Modernizer. Another site, maybe you have some CMS content somewhere and you want to create a custom data source and create a static site based around some products in a CMS database somewhere. And finally, Sculpin needed to be able to be installed globally. I wanted something like Composer, where you run the installer, get a FAR file, run it. And I just really wanted it to be super easy so that people wouldn't have to monkey around with getting Composer first and all these other things. Sculpin actually started out most of its life being a typical Composer-managed application. What this entailed was creating a Composer JSON, requiring Sculpin, requiring any additional packages, components or plugins, themes, whatever. And a lot of that doesn't exist yet, but in theory they do. And then running Composer install. And the end result is you end up with your site. And everything is good in the world. What actually happens is this file. You have Sculpin, you require your components, and the obligatory composer-enforced whitelisting of dev packages. Since we're relying on Symfony 2.3, there's really no way around that. It's pretty ugly. It's probably one of the biggest downsides to working with this right now. And finally, composer configuration to inform the component installer where to install the components. Run composer install, and afterwards you're able to run vendor bin sculpin, generate the watch flag, lets you watch the file system for changes, and server instructs it to start a web server to serve the files that it's creating. What happens is that composer installs over 45 packages. This is not necessarily the best first impression for some people. 45 packages come down, you start seeing Guzzle, you start seeing React, Composer itself, and you're thinking, you're taking my markdown file, you're converting it to HTML, what is all this other nonsense? Why do I need to see this? Why is it there? In reality, this can be handled by doing a global installation. Global installation would be if you want to download like a FAR file, you want to do a source install and put it in a directory, a development version you want to have in some directory, someplace where you can use it for multiple sites. This isn't just about getting rid of downloading the internet problem. It actually is a usability thing that some people will actually prefer it. There are benefits to installing using the traditional composer. The normal things that you have with the lock files and whatnot, you can ensure that my website is being built with this version of Sculpin, with all of these dependencies, and those type of people who really care about that are going to be fine with the fact that they have to install 45 packages in addition to what they needed. In order to support both of the features that I mentioned before, of being able to do site-by-site specific plugin installation and the global installation, the application itself needs to be extensible at runtime. And what that means is that you're taking an application with known dependencies that are known to be installed. You can get a FAR file, it has all of its vendor packages in it. They're installed, those files are there. And then you need to extend it with additional dependencies based on the directory you're in. So that is what it means for an application to be runtime extensible. Some of the things to keep in mind when you're talking about runtime extensibility is that the application is going to have dependencies. That's kind of a given. The project may have its own dependencies, and the project and its dependencies may also depend on the application itself. In the case of a plugin, this makes a lot of sense. So say in the case of Sculpin, you have a data source interface. If you write a plugin that creates a data source interface that talks to a database or talks to your API or whatever you want, that plugin itself is going to need to have access to the data source interface. So it is going to depend on the application itself. The biggest problem that needs to be handled is that the dependencies for the application are already installed. Now, that was kind of a given earlier, but this is actually the hardest part. And this is where we need to talk a little bit about how Composer works. Specifically, we need to talk about repositories. Composer's repositories are basically a collection of packages at specific versions. It's not one package at one version. It can be one package at many versions. How many people have worked with repositories in a Composer JSON? OK. So those are the typical repositories. They're the VCS repositories, Git, Subversion. There's some service-specific drivers like GitHub, Bitbucket. There is also the Composer repositories. Composer has an inherent Composer repository pointing at Packagist. This is why Packagist is so important right now. Everybody has access to it unless you explicitly disable it in your Composer JSON or your Composer configs. You can run your own instance of Packagist. Is anyone doing that? OK. Is anyone running Status? Okay. So those are basically the same kind of package repository. There's the inline package repository, like if you have something that isn't in any way composer friendly, either the vendor doesn't care or it's outdated stuff that you need to write on your own. You can do inline packages, and Composer handles that fine. There's also pair. Composer uses some other repositories internally. These aren't things that normal people see very often. There's a local repository. There's the platform repository, and there's the additional installed repository. Does anyone know about any of these? Has anyone played with these before? One person, okay. So this is going to be new. The local repository, it's a repository that contains a list of everything that's installed. So this is created after you do composer install or composer update, and it writes to vendor composer install.json. Who's seen this file? Okay. Is anyone actively working with it? To parse it, play with it in any way? Okay. It contains everything that you install. So if you do composer install, great. Representation of this would be a simple package. Acme My App requires Twig, and after composer solves the tilde 1.10, it ends up putting twig 112.3 into the local repository, which gets installed here. It sounds a lot like the lock file. In many ways, it sort of feels the same. I don't know exactly how else it's used, but it is used when you do composer install and the lock file, someone else has checked in changes to your lock file. Composer will open the local repository and say, hey, these are the versions of everything that I have installed. And then it opens the lock file and says, these are the versions of the things that need to be installed, and basically removes things or upgrades things as needed. So they are similar. You'll check the lock file into the into VCS usually, but the local repository never is. It's supposed to be a snapshot of what's actually installed in that directory. There's also the platform repository. It contains a bunch of virtual packages. These are programmatically created by Composer itself. They represent things that are immutable. They're fixed. They can't be changed. Think things like PHP version. That's not going to change at runtime. That does not change depending on any external factor. PHP is running at the version it's running at. An example would be here, where we are actually creating the virtual package for the PHP interpreter. This is a little tiny snapshot of actual Composer code. Explores some constants, creates a complete package, and then adds it to the platform repository. So this is how we get things like extensions like GD, the international extension, and the curl libraries. So platform packages are how you can do things like require a specific version of PHP. You can require PHP greater than equal to something. That's where this comes from. If you require a specific version of a library or an extension, that's where these come from. Again, they can't be changed. They're all programmatically created by Composer. And they are used by the solver to satisfy dependencies. So you can require versions. You can require versions are a certain size. They're just installed. But they can't be upgraded or installed themselves. Again, because it doesn't make sense. You can't upgrade the version of PHP. You can't change the version of libcurl. They are what they are. The third type of repository is the additional installed repository. These are very similar to the repository, the platform repository. It can be used to inform Composer about other packages that are supposed to be treated as if they're installed. The big difference is that you can control it. This is not something that Composer has any say over. So for example, we're going to create an additional installed repository. It's just going to be an array repository. We're going to create a complete package called Acme Fabricated and a specific version. The way that this works is that you take the composer installer and you add the additional installed repository to it. The additional installed packages are similar to the platform packages. They are used by the solver to satisfy dependencies. They cannot be updated. The biggest difference is that you can control them. So as the developer, you can say what is in there and what's not. This concept of additional installed packages was added to Composer specifically for embedded Composer. The whole idea that you're going to have dependencies coming from something else and being added to the solver set. So we're going to walk through a quick example of what this all looks like as far as the repositories and how they interact with each other. Here we have a simple Acme MyApp, requires Twig at a specific tilde version. Run composer install. The solver takes that and spits out a local repository that has twig 112.3. So this would be the case of the actual end application running. Now we're going to create Acme MyApp project. This would be a project that is using the application and has some things set on it. We are going to require Acme MyApp, and we're going to require a plugin called Zim. Composer install feeds this to the solver. The solver looks and says, OK, Acme MyApp requires Twig, and you're requiring Acme MyApp. So you end up with a local repository that contains Acme MyApp at a specific version. It includes the plugin that you installed for Zim, and it also includes the MyApp Twig extension that is required by MyApp itself. This is pretty much embedded Composer, at least the way that it was in the beginning and sort of what started all of this. What we do is we use the local repository of the application and treat it as the additional installed repository and feed that to Composer. What this does is when you run MyApp Composer install, so this is actually Composer inside of MyApp Composer install will look at the additional repository and say, hey, Twig's already there. I don't need to install it. All it ends up installing is Zim. And it does this because it's using the local repository as the additional repository. So this is how we can make runtime accessibility work for Composer and a PHP application using an embedded Composer. What else do we need to know? Solving the dependencies, that's a huge hurdle. Making sure that you know which things are already installed and not installing them, not getting duplicates and randomness that happens. We also need to know where those files live. And we also need to know about its class loader. That is where the vendor directories and class loaders come in. Because Composer is going to install all of the dependencies and the class loader for the application itself, and it's going to install the vendor directory and the class loader for the actual project. It's not hard to actually manage all of this, but it can be done a little more easily. And that is where Embedded Composer comes in. Embedded Composer is up on packages. It's on GitHub. Anyone can take a look at it and start poking around. It's a set of packages and some conventions for making it easy to embed Composer into a Composer-based application. So it's useful for any application that wants to interact with Composer. The primary use case so far for me has been Sculpin. So command line applications are kind of its strong suit right now, but it's definitely able to be used by anything. If you have a web-based GUI that you want to enter in, hey, I want to install this package, you can use Embedded Composer to basically update the dependencies and write everything out. Where did it come from? It came out of Sculpin. I ended up looking at it and trying to find out which things I could rip out to make it usable by anybody. It seemed like something that could be pretty useful for people to be able to, use plugins and whatnot in their own applications. The packages, there's the kitchen sink. It's the main package, dflydev embedded composer. There's a core. There's a console, which right now is basically just Symfony console. It maybe should have been named a little more specifically, as there could be other console-based libraries out there that we could create. And then there's embedded composer bundle. A little bit about the core. There's some concepts that became kind of complicated when you start talking about, okay, I have this application. It can run in both contexts. It can be installed, via FAR. It can be installed as a typical composer install sort of situation. So kind of the conventions I've been using is that the application is always what's going to be run. So the application in Sculpin's case is Sculpin, Acme My App, whatever you want to call it. Whatever is the thing that will be run, whether it's embedded or not, is considered the application. The project directory is an isolated instance of that application. So like in Sculpin's context, that would be a website, like an individual website where you're going to run the Sculpin binary. Whatever use case you come up with, the project would be considered the directory that you're using to extend the application that you're running. There's also a concept of internal versus external. This was even more complicated. Embedded Composer has two repositories. It has an internal repository and an external repository. Without any context at all, it's hard to know what that means. And consistently, I needed to come up with a way to make sure it's not too confusing for people. So the internal, anything that's marked with internal, is going to be the embedded application if it was actually installed globally. So for instance, the internal repository will be empty if you include Acme My App as a dependency and you use a typical composer install. If you use Acme My App binary or script to run composer install, in that case, the internal repository is actually going to be the stuff that was in the FAR or the wherever you have My App installed. The reason it's really confusing is because of the fact that it can be both. So this is something that can, I imagine this can trip people up. It tripped me up for a long time even writing it. The main thing is that it comes down to where the class loader is located first. That helps determine whether or not that there is going to be an internal repository or not. So that brings us to the bootstraps. These are boilerplate things that are mostly copied from Composer source code because Composer source code is pretty cool. Typical application, include if exists, the autoload file. If that fails, it tries to look at it elsewhere. The rest of this, boilerplate stuff, the end, you include myapp.php. It's basically the next step in the chain. This is how it breaks down. Since you know your application, you know that if it's installed globally, the autoload file is going to be in a specific location. Vendor is hard-coded here. You may actually be using something else if you override the vendor directory. You, as the application writer, writing an application that you want to embed Composer in, will have to manage this. In the case of a typical Composer installation, the internal repository will not be used because it knows exactly where it's all in the same class loader. So that would be the case if the autoloader can be found by basically relative checking through the application itself. This is a little bit of optimization that may or may not be important. You can be a little more explicit if you want to do a FAR, because you know exactly where it should be. And if it's not there, there's something horribly wrong. And you can warn them appropriately. You may also want to do some extra checking or set some constants or define some things if you're in a FAR context so that your application behaves a little differently. So it's not a bad thing to create like a FAR stub. Inside core, there's a builder. Builder is used to build the default implementation of Embedded Composer interface. You can see it here. This is an example of what binmyapp would look like, or binmyapp.php. This needs to be called really early, just to make sure that everything gets set up properly. We take the class loader and send that in, and we send the project directory in and build. It's pretty standard builder type things. Unfortunately, the project directory doesn't work right now. I'm including it in all of the boilerplate that I've been writing because it should be working, but there's actually a lot of work that needs to be done in Composer to support this. It's actually a Composer restriction. All throughout Composer, there's a lot of get CWD calls. So hopefully we'll get to this, and then at that point, this will start working. But for now, you pretty much have to run the application from the directory that you want to be considered the project directory. So what can we do? We have an embedded composer instance created from our builder. What does that get us? Well, the first thing that we need to do, in pretty much all cases, unless you have very specific reasons not to, is that you want to enable any additional autoloaders. This only happens if you have an internal repository. This would be the case where you have a FAR that has an internal repository, like an install JSON that says, hey, my application has twig already. In that case, you also need to load the autoloader for your project that says, hey, I also have RickNZim, and this is where it's at. So the process autoload command should happen pretty much right away to reduce the risk that you're going to try and use a class that doesn't exist yet, which is a real problem. Everything up to this point assumes that your app actually has Embedded Composer installed in it and has Composer and basically everything that it needs. So far, everything that it needs pretty much just entails Embedded Composer. So Embedded Composer will bring Composer in with it. But if you try to use anything else before this, there's a possibility that it will actually fail. So this needs to be called every time to make sure that the entire autoloading chain is set up correctly. What it looks like is really simple. It literally looks to see if it has an internal repository. And if it does, it requires the external vendor directory's autoload. So this is a good example of internal versus external, and where it's really important to keep them in mind conceptually. Because there's a lot of things like this where the builder has determined exactly where the external vendor directory is, and it makes everything else a lot easier. But if you don't know what the difference is between external and internal, it could get really messy if you try to figure it out on your own. We can create an embedded aware composer. Now this is actually a composer instance. Rather than having to figure out the factory method to create a composer instance yourself, this takes everything that embedded composer knows about itself and creates a composer instance that is fully aware of its environment. This is true whether the application is running as an internal application or an external application. All of that is abstracted. It works the same no matter what you're trying to do. The only thing is that you need to pass in an I/O interface. You can probably pass in null I/O if you want to, or if you need to build a web GUI, you could create some sort of web console, or you can use the standard console that Composer uses. You can create an installer. This is another factory type method. This creates an instance of Composer installer. That's sort of the workhorse as far as Composer is concerned. It actually does everything to tell the solver, look up things, tell the solver these are the repositories that I have, tells this, the solver which things are already installed, actually goes to the repository manager, the installation manager, all of the things happen inside of Composer installer. And this creates it for you, and all you need to pass in is an I/O interface. If you call the run command on this with the proper things, proper additional values set, it will install exactly what it needs to, where it needs to, regardless of whether you are in an embedded environment or not. It handles all cases. So this is a quick example of what the Composer install command looks like. This is actually Composer / console or / command / install command with one minor change. The minor change is that instead of using Composer's factory methods to create the installer, we are creating the installer from Embedded Composer. And everything else is the same. All of these extra settings, it's all good. We automatically set the internal repository if it needs to. The installer just does exactly what you expect. Embedded Composer lets you find packages just based on their name. It does some fancy lookups to ensure that you get the alias package if there are alias packages. Turns out that's the opposite of what Composer would normally do. Composer's find methods would normally return non-alias packages for what it considers canonical. This can be useful to get a package by name. If you think it's installed or know it's installed, then you can do whatever you want to with it. So this will work whether it's from the internal repository or the external repository. If you want to get Sculpin, you can. If you want to get Twig, you can. Just ask for the name and you'll get the actual package that is installed. So I've seen a couple of projects over the last couple of days as I've been talking about Embedded Composer on Twitter. Some people have some web interfaces that list things like, hey, this is what's installed in my project right now. This is what version was required, and this is what actually got installed. This would be a way to do that without having to parse any files yourself. The debt that you get with that is that you have to install Composer along with your application, and that could potentially be a deal breaker for people. But it is probably a better way to do it because you're actually dealing with Composer internals, Composer API. You'll be getting everything exactly the way that Composer would be getting it. Additionally, Embedded Composer interface provides direct access to the external repository and the internal repository. If you need to somehow make a distinction, these things were installed by the package, get the list of packages from the internal repository. If you want to show the things that were installed in the directory, you would get the external repository. Hope I didn't mix those two up just now. Basically, you can find out exactly which is in which repository using these methods. If you just want to know all of them, there's a composite repository available also via just get repository, and that will give you a repository that is a composite of both internal and external. The console package, there isn't a lot to say about this. It's basically the screenshot I showed earlier. It has the install command and the update command, slightly modified to use Embedded Composer. It also requires that the application be Embedded Composer aware, which is problematic unless you're writing your own custom application, in which case you probably are if you're going to be using Embedded Composer. I'll show something a little later to show why this doesn't quite work with Symfony's basic application yet. And that is in the bundle. This is a work in progress. I'll show kind of where it's at right now. It's broken, but sort of looks like it works. It just kind of gives an idea where this is eventually going to go. Composer JSON, you'd add Embedded Composer bundle. App kernel, you would do your typical, install this bundle. App console list, after you run composer update, will show you have two commands, composer install and composer update. So it registers them just fine. App console composer install, yeah. So this doesn't work, but eventually either we'll have to add embedded composer to Symfony or find some other way to get these things to work a little better. The best solution would probably be to get embedded composer added as a synthetic service into kernel and have it get it from the kernel instead. But if anyone tries this, this is what you'll see, so probably don't try this just yet. If you're writing your own application and you have your own application subclass, just implement embedded composer aware and find a way to get embedded composer added to the application when it's created. Sculpin is doing that currently. It's not terribly difficult. So the bundle works. It just requires some additional tweaking to the application if you actually want to use it. So, there's a couple of issues to keep aware of and some workarounds. One thing that really surprised me, and there's a couple of gotchas that once you start working on it, suddenly you're like, oh, well, clearly that isn't going to work, but you don't realize it until later. One of them is that if you embed Composer into your application, check it in, send it up, someone else downloads it, how do they run it? Especially if that instance of the application requires code that needed to be added, like a plugin. This would be similar to having app kernel including a bundle that hasn't been installed yet. Well, if your installer is the application and the application is set up in the code to load code that doesn't exist, it's kind of a chicken and the egg problem. So one of the ways that I looked at solving it is to add a safe flag. So Sculpin has the safe argument. If you run --safe, it bypasses registering all of the other commands and only adds composer install and composer update. So the end result here is that even if you don't have anything installed except the application itself, you're able to still install new dependencies or update dependencies or break anything that's fixed or break anything that's broken. There's currently a problem with the fact that the root package isn't actually installed as far as Composer is concerned. So this is, you have your application, like say Sculpin, and I run Composer install. The install repository contains, or the local repository contains everything that is installed except for Sculpin itself, because no one really needs that. It wasn't something that was terribly important to Composer's use cases so far. There's a PR for this right now. It's kind of in limbo. I'm not terribly sure it's the right way to do it. But it's something that will hopefully get fixed later. To help illustrate this, I'm going to take this slide that I showed you guys earlier, and I don't know if anyone noticed this or not, but where's Acme My App? It's not in the additional installed repository. It's not in Zim. It's not in the local repository. This can be handled by a script. The script's job is anytime the autoloader is generated, it is going to dump what it thinks is the root package into another repository. Composer install, composer update will both trigger this functionality. So the file it writes to is vendor dflydev embedded composer root package.json. It's exactly the same as the local repository, the vendor composer install JSON. The only difference is that it only contains the root package. So in the case of Sculpin, this would only contain Sculpin at whatever version you ran composer install on. In the case of Acme My App, it would be Acme My App, whatever version it's on. What this does is it gives us the ability to put in what was missing. we use the local repository, just like we were before, which had the twig dependency. The root package repository, which is added by the composer script, includes Acme My App at a specific version. We combine these two as a composite repository and use that as the installed repository. Now the additional installed repository contains everything it needed. It has Acme My App, it has twig, and we get Eric and Zim. So between these two now, the solver has everything, and Composer is completely aware of everything that's installed. This will hopefully go away soon. We either need to standardize this concept of a root package repository, or the root package somehow needs to be added to Composer's default local repository. I'm not sure exactly where that's going to be, but until then, the Composer script can handle this for us. Another problem that wasn't immediately obvious to me when I started was that there'd be some lock file thrashing. What this means is that if you switch between using embedded Composer to internally handle package management and doing a typical Composer install, Composer update, they're both going to fight over Composer lock. And I will use a little example to show how bad this can be, and then it'll be a little easier to understand. So I have my website. I run Composer install. It downloads the internet, and the important thing is it writes a lock file. So what's in that lock file? Everything that just got installed. All 41 packages, 48, however many it is. OK, I checked this in, and I asked someone else to help me with my website. And they think, hey, cool, Sculpin, I'll just download sculpin.far and run Sculpin update. Sculpin update says, hey, look, I've got 41 things installed in my FAR because I'm embedded and I have all these things. It looks at the Composer lock file and says, or actually, yeah, it looks at the lock file and says, I have all these things installed. Sculpin's embedded Composer says, I don't need those anymore. So I'm going to remove all 41 of them and write the lock file. And that's where it gets really kind of messy, because they check in this code, because you check in lock files. Now I want to go back and I want to run Composer install after I've done a git update or git pull. And I get this nice message, because it's installing from the lock file. And it may not be immediately obvious what's going on here, and in some cases it may look like it works. I just lucked out in this example that aesthetic requires Symfony process. Symfony process happens to be included inside of Sculpin. So it is one of the 41 packages that Sculpin decided to remove. This means that my Composer doesn't know anything about Sculpin's dependencies. It only knows what's in the lock file. And the lock file says, I need process. I need Symfony process, otherwise go away. So this is a problem. And in order to get around this, you basically have three options. One of the better ones is to change the name of the Composer file name. Instead of using composer.json, you can set it to anything. In this case, I'm going to use myapp.json. In the case of Sculpin, it's sculpin.json. And I can also set the vendor directory so that they don't fight over that as well, which that also happens, but I don't want to show that. Called build, and you end up with an embedded Composer instance that is aware of these alternate file names and directory names. So you really get three options. You either require consistency. You can't mix and match global installs and typical Composer installation. You don't check in the lock files. That's another valid option for some people, and in some cases it may not actually matter all that much. But sometimes that might just be a good sign that something's kind of dirty and you want to try something else. The third option is what I was showing on the previous slide. You can segregate your application configuration from anything else. And basically that means that that configuration file is only going to be modified by another version of Sculpin or something else that for some reason reads the sculpin.json file, which probably isn't going to happen. This also means that you can have Sculpin living inside a package that might have other PHP files. So you can have composer install happen. It'll install the vendors. It'll read to composer.json. And maybe you're going to use Sculpin to generate a little documentation site based on the contents of that package. They won't fight anymore. And you can have Sculpin completely independent of anything else that you have. Some hints and suggestions for using this based on the stuff that I've been working on. If you want to build a FAR, there are certain things that you need to make sure are included in the archive. Has anyone used Box to build a FAR? It's really cool. The first FAR builder I saw was Composer's compiler. It's kind of complicated and did all these things. And basically, I replaced all of that with this box.json. And it says which things you need to include, which things not to include. You can exclude tests. You can make sure that all the JSON files are included except for composer.json. You can look in bin source vendor. Like earlier, I was showing the FAR bootstrap. You can require the FAR stub right here. It's all pretty handy. The important things, though, are making sure that you include the vendor composer install the JSON. That would be your application's local repository. If you don't include that, Composer falls apart, or well, embedded Composer falls apart, and you don't get anything going on. You also need to include currently the root package JSON, because that includes the record of what you actually installed. So in the case of Sculpin, it's Sculpin. In the case of my app, it's my app. With this file, run box build, and anywhere from a couple seconds to a minute later, you can run my app FAR, get the version, you're good to go. Everything is in there. At this point, my app is completely capable of running in an embedded environment. Application version, Box makes this pretty easy. It's pretty typical stuff, but it just does it automatically. It's pretty cool. By specifying get version, that means at get version is going to get replaced by the commit hash. It does that automatically. It's pretty nice. Pretty version is something that embedded Composer can help with. Basically, you ask embedded Composer to find your root package. In the case of Sculpin, that's Sculpin, and you get the pretty version of it. So if you've installed from a working directory and it's not actually a commit, you end up with something like this as your version here. If you have a git version, which happens when Box actually builds, so you know that you have it built on a specific commit hash instead of something that might be a dirty directory, it includes the short commit hash. And if you build it on a tag, it knows its tag as well. So in the case of Sculpin, this gets a really nice thing. You want to know what version it is, which build it is, if it has a commit hash or not. It works pretty well. I've been asked this question a lot since I've been talking about this, especially here. People say, oh, you're speaking? Yeah, great, embedded Composer. Why would I want to do that? Just a quick survey. Does anyone feel like this question has not been answered? Does anyone still wonder what kind of use cases there might be for installing or using embedded Composer? OK. This is the question that I would like to be able to answer pretty well for people. Kind of came up with a couple of ideas. Sculpin is a good case. It's a command line application. Turns out there's actually a lot of command line applications that could potentially be useful. PHP unit would be a case where maybe you want to have the static analysis stuff in one in one project, but you might not want it in another. And you might want to just have PHP unit installed at a certain version and extend it on a directory by directory basis. There's a couple of other things on here. Frozen, of course, is another static site generator. Fing is something that is pretty embedded into pairs, so it's probably not likely that it's going to be able to do this anytime soon. But it has a lot of plugins and optional things that can be added to it. Like for a long time, there were like git commands that could be run. This would be a way that, you know what, my project needs git, and I want to extend Fing with the git components without having to run Pyrus or pair or whatever. Whatever it is that you have to do to get pair running, I still have issues with that. I'm really happy about Composer, in case anyone hasn't noticed. You can use the same things for a GUI. The internal concept doesn't make as much sense if you're talking about a web-based application. It's still safe to use. It just doesn't necessarily make sense unless you're distributing your web application as a FAR, in which case it would make total sense. I just haven't really explored that very often. So I wanted to show Embedded Composer in action. It's also an awesome opportunity to show more about Sculpin in real time. Previously, I said that I wanted Sculpin to be able to have plugins on a site-by-site basis, and I wanted to be able to have Sculpin installed globally. So if anyone wants to follow along with these commands, you can do so right now, and 95% chance it'll work. Probably not. So we're going to basically create an isolated directory in temp Sculpin demo. We're going to go in there. We're going to run the installer and get Sculpin. And this is going to represent our global installation of Sculpin. It's going to live in one location, and everywhere else I'm going to use it will come from here. Next, I'm going to clone my website. And I'm going to run the version of Sculpin I just downloaded. I'm going to tell it to install, which is going to resolve the dependencies for this particular website against the version of Sculpin I just downloaded. And what gets installed are some components. Has anyone seen the component installer yet? OK. Component installer is awesome. It lets you install front-end dependencies. It's basically Beau or however it's pronounced, and all sorts of things mixed together in one. People are creating Composer shims to let you install these things. So I decided for my website, I wanted font awesome, jQuery, modernizer, and normalizer. In addition, component installer needs to be downloaded as well, so that gets installed in this directory. And it requires aesthetic. So basically, there's 6 total dependencies that get installed for building my website. Not 41, not 48, not 30. It's fully capable of getting exactly what it needs. Now I'm going to run Sculpin FAR. I'm going to tell it to generate the site, watch the file system for changes, and serve the files that it generates. And it works. Fires up a development server, localhost 8000, and you hit Control-C when you're done, and my site builds exactly like I would expect. So to continue the demo, we'll go back to the main directory where everything's installed, and we're going to try another site. We're going to get the Sculpin blog skeleton, which is just kind of a throwaway site that people can look at to see sort of what's available, and you could take it and run with it or start completely from scratch. CD to the directory that you just cloned, run Sculpin FAR install, and here we have a completely separate set of dependencies. In this case, we get jQuery, Bootstrap, and Highlight, and also the component installer and its dependency aesthetic. Run generate, watch and serve, and you get the website exactly like you would expect. Quit the server by doing Control-C, and go back and clean up your directory if you want to. The end result is that Sculpin supports plugins on a site-by-site basis, which was the first requirement. My website had different dependencies than the other website, and they played nicely. Sculpin worked exactly as expected, and it didn't involve completely solving everything and installing all of Sculpin and its dependencies, which means that Sculpin was able to be installed globally. So it sort of fit both. And this is pretty much the end of the talk. If you have questions that you want to ask after the fact, you can hit me up on Twitter. You can find me on IRC in a couple of channels. And you can, of course, leave awesome or horrible feedback on Joined In. And if you want to find the code, again, look for Embedded Composer on GitHub and on packages. Any questions? So I'd been told to prepare a question in case I got crickets. Oh, Pablo.
Do you think that Symfony could use this work to install the bundles?
Yes. I think that it would be tricky because of the safe problem that I mentioned. You can install the bundle and then add the code to register it. If you add the code to register it and try to install the bundle, it's not going to have the bundle to register yet. So Symfony, or the console app right now would just die. It would say, hey, I don't have that bundle you wanted. So it's a kind of an order of operations sort of thing, which it's not insurmountable, but it's probably not super trivial. The other thing is that would require Symfony to depend on Composer. Well, it would have to depend on Embedded Composer, which depends on Composer. And that slide I showed earlier, where there's currently 7 or 8 dev whitelists. I don't know. It's definitely something that I think could be useful. I just don't know how well that will be received. Yes? What's that?
Would be applicable for Drupal-like.
Drupal? Yeah, well, that's something that I don't know much about Drupal, but I keep hearing about Drush. And I don't know what Drupal is currently doing to work with Composer. I know that they're keeping that older technology that they're using for installation stuff intact and somehow using Composer with it. But this could totally be something where, if you upgraded Drush to use Embedded Composer, it could possibly do everything at once and resolve everything together. So it's something that I would love to talk to someone about that and see if it's something that could be added. Any other questions? All right. Well, I think I'm almost out of time, so if there's no other questions, I guess that's it. Cool.